You wake up, Earth is flat now. Before you even open your eyes, gravity has already changed. Not gone, just different. And that difference is the whole problem. Most flat Earth arguments online go the same way. Horizon photos, curvature math, back and forth. All of that skips the part that actually matters. Nobody asks what a flat Earth would have to do physically just to survive one single day. So let's actually build one. Picture a disk, land and ocean spread across the top, presumably some edge or ice wall holding it in, the sun and moon circling somewhere above. Simple enough to imagine. Here's where it starts falling apart. On a sphere, gravity pulls toward the center, so down means the same thing everywhere you stand. On a flat disk, gravity still pulls toward the center of mass, except the center is no longer beneath you. It's somewhere in the middle of a giant plate. Unless you happen to be standing on that exact spot, gravity is pulling you sideways just as much as it's pulling you down. You wouldn't notice right away. Gravity doesn't announce itself. No dramatic tilt, no alarm, just a slow growing wrongness in your knees. The sense that you're leaning, even standing perfectly still. Walk toward the edge and it gets worse. Down stops feeling like down. It starts feeling like standing on a hill that never levels out. You're climbing, even though your eyes swear the ground is flat. And you're not the only thing gravity is dragging sideways. Water doesn't care what your eyes tell you. It follows gravity exactly. So every ocean, every lake, every drop of rain starts sliding toward the center, pulled by the same sideways tug, making your knees ache. Give it a few days and the oceans stop being oceans. They become one enormous rising sea in the middle of the map, while coastlines at the edges dry out and redraw themselves day by day. The air does the same thing. Atmosphere isn't glued to the ground, or it's held there by gravity, same as everything else. So it piles up thick over the center and thins out toward the rim until somewhere between the middle and the edge, you'd cross a line where there's barely anything left to breathe. Now, you might be thinking, okay, strange gravity, migrating oceans, thinning air. Weird, but maybe survivable near the center. Fine. Let's leave gravity alone for a second and check something else. The sky. On a globe, the sun rises and sets at different times, depending on where you stand, because you're standing on a curve, tilted at a different angle than someone on the other side of the planet. That's why it's midnight in one place and noon in another, at the exact same moment. On a flat disk, there's no curve to explain that. If the sun is a light circling above a flat plane, everyone under it should at minimum see it in roughly the same direction at the same time. Instead, half the disk would need to somehow be in shadow while the other half sits in daylight, with no globe to cast that shadow. You can bend the model to try to explain it. People have. Every version ends up needing the sun to shrink, spotlight, and behave like nothing we've ever measured a light source to actually do. Seasons make it worse. On a sphere, seasons come from tilt, different parts of the planet leaning toward or away from the sun over the year. On a flat disk, there's no tilt to lean, so the sun would have to spiral in toward the center for summer, then spiral back out towards the edge for winter, on a path that somehow keeps every region's day length correct at the same time. Nobody's ever produced a version of that path that actually matches what we observe from the ground. Not one. At this point, there's a common comeback, and it deserves an honest answer instead of a dismissal. Some flat Earth models don't use gravity at all. Instead, they claim the disk itself is accelerating upward forever at the same rate gravity would produce. And that's what presses your feet to the ground. It's a clever fix on paper, except accelerating upward forever means going faster every single second with no upper limit. Do that for the age of a several thousand-year-old flat disk, and you're already moving at a meaningful fraction of the speed of light with no source of fuel or energy anywhere near large enough to have caused it. The model doesn't just lack evidence, it runs directly into how energy and motion work at all. So the sideways gravity thread and the sky thread both lead back to the same wall. Whatever shape the disk is supposed to be, it can't produce the physics we actually observe. And here's the part that finishes the idea off completely, and it's got nothing to do with maps or horizons. It's about what gravity does to any large amount of matter, given enough time. Every planet, every large moon, every star you've ever seen in a photo is round for the exact same reason. When you have enough mass gathered in one place, gravity pulls every part of it toward the shared center, equally in every direction. A sphere is the only shape where every point on the surface ends up the same distance from that center. That's not a coincidence. It's the shape gravity settles into once nothing else is stopping it. A state called hydrostatic equilibrium, and it's why you've never seen a cube-shaped planet or a disc-shaped moon. A flat disk has no reason to stay flat. Its edges sit farther from the center of mass than they should, so gravity keeps tugging them inward and downward, the same pull already dragging the oceans and the air toward the middle. Slowly, the whole structure starts folding in on itself, edges curling towards center, until geologically fast, not instantly, but fast on a planetary timescale, it stops being a disk at all. It becomes a sphere. So here's the strange part. Even inside this hypothetical, even if you genuinely woke up tomorrow and Earth was flat, physics wouldn't leave it that way for long. The same gravity that changed the moment you opened your eyes would spend the following stretch of time quietly undoing the entire premise, pulling the oceans back into balance, thickening the thin air at the edges, and folding the whole planet back into the one shape it can actually hold on to. You didn't wake up on a flat Earth. You woke up on a planet in the middle of turning back